Okay, now let's look at a special kind of pattern. If you take binomials, so two terms, and then two different exponents, and go ahead and expand them. Of course, anything to the 0 power is just 1. X plus y to the 1, of course, would just be 1x and 1y. But then if we did squared and FOILed, we'd get 1x squared, 2xy, and 1y squared, and so forth. For the rest of them, if we then just looked at the coefficients, we have what is called Pascal's triangle. Okay, these are the numbers that went in front of the x and y terms. What's interesting about Pascal's triangle is that each number is the sum of the numbers that are just above it to the left and to the right. So for instance, 2 is 1 and 1, 3 is 1 and 2, 6 is 3 and 3, 4 is 1 and 3, 5, 1 and 4, 10, 4 and 6, and so forth. Each number is made by adding together the two numbers that are diagonally above it. And again, these numbers are the coefficients in front of the binomial expansions that we had over here on the left. There is another way to find these numbers, and that is using what's called n factorial. Okay, the little exclamation is the function factorial. Now, 1 factorial equals 1, 2 factorial equals 2 times 1, which of course is 2, 3 factorial is 3 times 2 times 1, which is 6, 4 factorial is 4 times 3 times 2 times 1. So notice how we just go down from whatever number we start at. We go down by ones until we get to 1. By definition, 0 factorial is just 1. Well, it turns out that the coefficients for a binomial expansion can be found by this pattern here, which sometimes you'll see written as NCR or N over R inside of brackets, and it equals n factorial over r factorial times n minus r factorial. And so this n and this r, as you see there, match up with those ones. In these particular problems, n represents the exponent in the expansion, and then the r represents the term in the expansion. However, r starts at 0 for the first term. So in other words, if you'll note, if I look at, for instance, this last one here, okay, so n was 5, so this would be the 0th term, and then the first term, second term, third term, fourth term, and then finally the 5th term. So if we look at 5c2, notice that we get a 10 after we plug in the numbers. 5 factorial, which would be again 5, 4, 3, 2, 1, all multiplied together, times 2 factorial, times 3 factorial, 5 minus 2 being 3, which would be 120 over 2 times 6, which is 10. And if I look at the third one, notice that my coefficient in front of the x cubed y squared was 10. Now you might say, well, wait a minute, that's a 2. Why did you say the third one? Well, remember that we start at 0. So 0, 1, 2, 3, 4, 5. Up here it would be 0, 1, 2, 3, 4, and so forth. So the kth term of a binomial expansion, we would use, here is this part that we had there, and then x to the n minus k minus 1, and then y to the k minus 1. So these two guys together, since that has subtract k minus 1 and that has k minus 1, if you put those two together, you always end up with n. And in fact, if we go back to the top and look at what we had before, note that here we have 5, n was 5. Here we'd have 4 and 1, again 5. 3 and 2, 5. 2 and 3, which is 5. 1 and 4, 5, and so forth. And so the exponents will always add up to what your n is. Now, please note that we are, of course, adding our terms, and so we have the formula, the sum of NCR, same NCR we had here, and then x to the n minus r and y to the r. Again, r is starting at 0 for our numbers. And of course, please note, up here, there was no y in the very first one. Well, if r starts at 0, we would have y to the 0, which would just be a 1. And here it would be 5 minus 0, so that would be x to the 5th, so that would be that one. So we could write out, following this pattern, if we were looking at x minus y cubed, we would have 3c0 x cubed y to the 0 minus 3c1 times x squared y1 plus 3c2 times xy squared minus 3c3 times x0 y cubed. Note that the x part, the first term part, starts at n and then goes down 3, 2, 1, 0. And the second term starts at 0 and then goes up 0, 1, 2, 3 up to whatever n is. And then, of course, if we go ahead and simplify, we end up with the same expression that we had at the top of the page. Now, on your calculator, if you want to do these particular kinds of functions, you need to use what is called the PRB. It stands for probability, the PRB button. And if you press it, you will have three functions come up. NPR, NCR, this is the one that we've been looking at. And then if you just wanted to do factorial, you see the little exclamation for the factorial. So for example, if we went for PRB and then moved it over twice, so notice I have 4 factorial on my calculator there, and then if I go equals, you can see that it equals the 25. 5 PRB, slide it over, and again hit enter. There's my 5 factorial, and then hit enter again, and I have my 120. Now if I wanted to do the 5C2 that I have up there in example, then I would go 5 PRB, move over to the NCR button, hit that, then hit the 2, then go equals, and notice it is equal to 10. Alright, so using our calculator, we can determine what these different values are. And so if I first do, I'm going to use the formula to begin with. So 4C0, well, that's going to be 4 factorial over 0 factorial times 4 minus 0 factorial. Again, I'm using the formula that we had up here for NCR. And of course, 0 factorial is defined as being just equal to 1. And 4 minus 0, of course, would be 4, so I'd have 4 factorial over 4 factorial, and we would in fact get a 1. Going by that same pattern, if I were doing 6C0, well, again, I'm going to have that 0 factorial, but then I'm also going to end up with 6 factorial over 6 factorial, which is going to equal 1. And then if I did 8C0, well, that's just going to be 8 factorial over 8 factorial, which again would just be 1. So, in general, anytime I have a 0 as the R, I'm going to end up with NC0 is basically n factorial over n factorial, which is 1. So anytime I end at 0, I will end up with my answer being 1. Note, if I go back to all my expansions, the first coefficient for all of them was a 1. Now, let's suppose that the second number, the r, was a 1. What would we get then? Well, 4c1 would be 4 factorial over 1 factorial, and then 4 minus 1 factorial. Now, again, I can do this with the calculator, but I just want to show you what's going on here. That's going to be, of course, 4 times 3 times 2 times 1. That's what the 4 factorial part is. The 1 factorial is just a 1. 4 minus 1 is 3, so 3 factorial will be 3 times 2 times 1. And so, note, those will all cancel, and I'm left with just equal to 4. If I did 6c1, I would end up with 6 factorial over 1 factorial and then 5 factorial. And again, the 6 factorial would be 6, 5, 4, 3, 2, 1. The 5 factorial would be 5, 4, 3, 2, 1. And so all I would have left is just the 6. If I did 8c1, that would equal 8. And in fact, if I did nc1, we would find out that this would be n factorial over 1 factorial and then n minus 1 factorial, and so this would just equal n. So for things ending in 0, no matter what number n is, our answer is going to be 1. For the next term over, r is now 1, so that's going to always be the second term. The second term will always equal n. And so if we go up to the top and again look at the second one, the second term, so again these were all r equals 0. Here's r equals 1. Well, that was 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5. The second term always had whatever the value was n. All right, I want to look at a couple more examples now. What if the two numbers n and r were the same? So 4c4 would equal, well, that would be 4 factorial over 4 factorial and then 4 minus 4 factorial. Well, that's just going to give me the 0. There's my 4 factorial, there's my other 4 factorial. In other words, it's just like this, except I've switched those two. This is going to equal 1. 6c6 will equal 1. 8c8 will equal 1. And therefore, the general form is ncn. No matter what value n is, that will just equal 1. Now, if I was doing 7c2, well, that's going to be 7 factorial over 2 factorial, and then 7 minus 2 factorial, which would be 7 factorial over 2 factorial, and then 5 factorial. Now, the top, of course, is going to be 7 times 6 times 5 factorial, because it's going to go 5, 4, 3, 2, 1. The bottom has 2 times 1, and then also the 5 factorial. So note how these will cancel. I'm left with 7 times 6 over 2. And so that is 21. Now, instead of doing it the long way, let's go ahead and look at our calculator. And so we'll go 7 PRB, move it over to the NCR, hit my enter, hit 2, enter again, there's my 21. Okay, now we're going to do the next one. 7 PRB, slide over to the NCR, equals, hit 5, and then hit equals again. Note this also comes out to 21. So 7C2 equaled 21. 7C5 equals 21. And it turns out that if you have the two values of n, or I should say r, excuse me, the two values of r, if they add up to what n is, you will get the same answer for them. And in fact, if we go up here and look, we can see 3 and 3, 4 and 4, 5 and 5, 10 and 10. We do double up when things are the same. If we think about, if we go up here for a moment, just look at our triangle. So this was r equals 0, r equals 1, r equals 2, r equals 3, r equals 4, and then of course r equals 5. Well, note 0 and 5 add up to 5, they're both 1s. 1 and 4 add up to 5, they're both 5s. 2 and 3 add up to 5, they're both 10s. And so forth. Up here it would have been 0, again that would have been 0, 1, 2, 3, 4. Okay, in this case 1 and 3 add up to 4, so both of them have the same value, and of course 0 and 4 add up to 4. Alright, let us use the pattern that I had in my sigma notation, this one up here, to do the binomial expansion of 2x minus 3 to the 4th power. So 2x subtract 3 to the 4th power, and basically all I'm going to do is follow the pattern. So it's going to be 4c0, 2x to the 4th, negative 3 to the 0. Okay, again, this will start off with whatever n is. The other one will start off with 0, and we have 4c0. Okay, then we'll have 4c1, 2x to the 3, negative 3 to the 1. Again, the two exponents have to add up to whatever your n was. The first term was going to decrease. Next one, 4c2, 2x squared, negative 3 squared. Then we have 4c3, 2x to the 1, and negative 3 cubed. And then our last term, 4c4, 2x to the 0, and our negative 3 is now to the 4th power. And so there are the 5 terms. Again, the first part, the 2x, went from 4, 3, 2, 1, 0. The second one, the negative 3, went from 0, 1, 2, 3, 4. And then our coefficient out in front, 4c0, 4c1, 4c2, 4c3, and 4c4. Alright, so what do these things equal? Well, we already said that anything that has a 0 for the NC0 will be a 1. And now this part will be 2x to the 4th power, so that'll be 16x to the 4th. And of course, anything to the 0 is a 1. 4c1, well, anything that has a 1 will then be the n. So that's just going to be 4. And then we'll have 8x cubed, and then times negative 3. The next one, we have 4c2. 4c2 will be 6 basically this is going to be 4 times 3 times 2 times 1 divided by 2 times 1, so 4 times 3, 12 divided by 2, so this one will be 6, and then we have 4x squared and 9. Then we'll have 4c3, so it's 1 less than that, so that's going to be a 4. And then this is times 2x, and then negative 27. And then finally back to a 1, another 1, and this one's 81. And so finally, putting all those things together, we have 16x to the 4th, subtract, because of that one negative sign, 96x cubed, plus 216x squared, subtract 216x, plus 81. Now we do have a formula to help you with the pattern. That is this formula up here. But in truth, if you just remember, the one starts out at n and goes down to 0, and the other one starts out at 0 and goes up to n, and then the coefficient term part, 4c0, nc1, nc2, nc3, and so forth, just remembering the pattern can help you get the coefficients for the binomial expansion. Alright, now what we can also do is use the fact that r starts at 0, that instead of having to do an entire thing, suppose that all we wanted was just a particular term. So for instance, we want just the 6th term of 2x plus 3y to the 12th power. Okay, well remember, for the 6th term, r is going to equal 5, because it starts at 0, so 0, 1, 2, 3, 4, 5. So the 6th term will be equal to 12, because that's where we have the exponent there, c5, and then the first one, 2x, this will be to the 7th, because basically I'm doing 12 minus the 5, and then the 3y part to the 5th, because these two have to add up to the 12 that I started with. So 12c5, if I go ahead and use my calculator, let's clear it, 12 probability NCR 5 equals, we get 792. So this part will be 792. This part we have 2x to the 7th, so that's going to be 128 x to the 7th. And then I have 3 to the 5th power, so that's 243, and then y to the 5th. And so now I multiply these all together, and I get, let's see, 24, 634, 368, x to the 7th, y to the 5th. And I was able to do this just by following the pattern. In other words, what I was really doing was following this form up here for the kth term. I wanted the 6th term. So notice how this is 1 less than k and minus 1 less than k. So since I wanted 6, 5 is 1 less, so 12c5. This is 12 minus 5. This is the 5. And then simply multiply all those things together and you have your result without going through all of that effort. So Very special case, Pascal's triangle and binomial expansion, but also showing you the power of when you know the pattern, you can get to the answer more easily than having to go through all of that work.